Hello, hello students. I am Nitin Deshmukh from GRYIP Institute of Pharmacy, Borawan. Today, I would like to explain about the precipitation titration. In precipitation titration, it involves the determination of halides like halogens, chlorine, bromine, iodine. It can be determined. Okay. Generally, this titration involves the titration of halides with silver nitrate. Because silver nitrate is used in this titration, so that it is also called argentometry titration. Sometimes mercurous nitrate is also used for the determination of halides. So it is also called mercurometry titration. So precipitation titration, we can say that is a titration which is useful for the determination of halogens. Okay. Now we'll go with the introduction of the precipitation titration. This is a special type of titrimetric procedure involves the formation of precipitate. Okay, during the course of titration, the titration react with the analyte, forming an insoluble material. Here we can use here the analyte we can use NaCl, potassium chloride, ammonium chloride. That means the analyte or compounds which contain halogens. Okay, that means KCl, NaCl, NH4Cl. Okay, the titration continues till the very last amount of analyte is consumed. The first drop of titrant in axis will react with the indicator, resulting in the color change and announcing the termination of the titration. Now here you can see the reaction. NaCl is a chloride containing salt. It is titrated against the silver nitrate so that the precipitate of silver chloride is formed with the NaNO3. Okay, and after the completion of the reaction, this AgNO3 again react with the indicator and it forms the complex with the indicator and gives the endpoint color change. Okay, this is two types. Actually, two types of titration is there: direct titration and indirect titration, or back titration also. Direct titration, that means here the titrant and analyte react directly. Okay, and some conditions are there in precipitation titration. Precipitate must be practically insoluble. Okay, this is the first criteria which is very important for the precipitation titration. The precipitate must be insoluble. Precipitation must be rapid, should be rapid, and possible to detect equivalence point with the help of indicator. Method based on the precipitation of insoluble silver is known as argentometry. Already I have discussed it earlier. If we use silver nitrate as a titrant, this is called argentometry. If we use mercurous nitrate, it is also called mercurometry. Okay. For the determination of halogens or halides, there are three methods. These are the methods which are used for the determination of halogens. Okay, first is Mohr's method, second is Boulhard method, and third one is Fazen's method. Okay, let us discuss with the Mohr's method. Mohr's method, it is first developed by Carl Friedrich Mohr in 1856. In this method, the chloride is react with silver nitrate, and here indicator is potassium chromate. Okay, in this reaction, silver nitrate is react with NaCl. NaCl is a analyte, and AgNO3 is a titrant. Is taken into the burette, and NaCl is taken into the conical flask. The AgNO3 and NaCl, it will react to give AgCl, that is a precipitate, and NaNO3. After the completion of, or at the equivalence point, AgNO3 is react with potassium chromate, and it will give the silver chromate, which is brick red in color. So that we can find out the end point of the titration. Here this is the reaction AgNO3 plus K2CrO4. Either K2CrO4 is a indicator. They are react with each other and silver chromate is formed, and this silver chromate is a red color precipitate. Okay. Now the limitation of Morse method. Main limitation is its pH range for the Morse method is 6.5 to 10. Below pH 6.5, there is an increase in the solubility of silver chromate. Okay. If we perform this practical or Morse method below 6.5, then the solubility of silver chromate will be increased. And above 10 pH, the end point comes too late. And silver hydroxide is also precipitated. If the solution is alkaline, make it acidic with nitric acid. Then neutralize it by adding sodium bicarbonate or borax. The main limitation is here, the last point, the reverse titration iodide and bromide cannot be titrated by or cannot be determined by argentometry or Mohr's method. Now the second method is Volhard method. It is developed by Volhard, Jacob Volhard in 1874. In this method, the method of estimation of silver ion in dilute acid solution by titrating against a standard thiocyanate solution in the presence of ferrous salt, a ferric ammonium sulfate. In this method, ferric ammonium sulfate is used as an indicator, and this is the titration in which we perform the back titration. Okay, this is the example of back titration. In this titration, we can estimate the chloride, bromide, and several analysis. Okay, here ammonium and potassium thiocyanate solution is used in conjugation with 0.1 m AgNO3 in the assay of substance which react with nitrate, but which cannot be determined by direct titration with silver nitrate. Already I have told you that this is the example of back titration. Okay, this is not a direct titration, it's a back titration. Excess of silver nitrate is used here in this method to the halide solution on known axis of silver nitrate is titrated. Okay. Second point, in this method to the halide solution, a known axis of silver nitrate is used and titrated with 0.1 m potassium thiocyanate or ammonium thiocyanate. And this solution is called Volhard solution or Volhard method. In this method, the precipitate of silver chloride is filtered off and the filtrate is titrated with standard thiocyanate solution using ferric ammonium sulfate as an indicator. At the end point, a permanent red color is produced due to the formation of ferric thiocyanate. So this method is also used for the determination of chloride, bromide, iodide by back titration. Why back titration? Because we use excess of silver nitrate here, and which is back titrated with ammonium thiocyanate or potassium thiocyanate. These are the reaction. Here analyte is ammonium chloride, which is react with excess of AgNO3. The AgCl precipitate of AgCl is formed. Then excess of AgNO3 is react with ammonium thiocyanate. It will form silver thiocyanate, and this ammonium thiocyanate again react with the indicator, and it will form the color change and gives the end point. Here the reaction is given here. ferrous ion, ferric ion, and thiocyanate, it will react to give this complex, which is red color. So this is the method of choice for the determination of chloride. Now the modified Wohlhard method, especially NaCl and KCl salt, can be determined by Wohlhard method. In case of chloride, it is useful to filter off a silver chloride or coagulate the precipitate by means of either dibutyl phthalate preferred or nitrogen. Okay. The excess of silver nitrate is back titrated with potassium ammonium thiocyanate using ferric alum as an indicator. Only the method here we use in this method, dibutyl phthalate or nitrobenzene is used for the determination of chloride and other halogens. Okay, so this is the modified Wohlhard method. Why these materials are used? The nitrobenzene and dibutyl phthalate is added to coagulate the silver chloride precipitate so that it will not interfere with the titration of excess of silver nitrate by forming a layer over silver chloride, and this avoids the need of filtration. So this is all about the Morse method and Wohlhard method.